Now, yesterday we talked about chords and arcs, and we said that if we have two endpoints on a circle, the line segments that connect between these two endpoints are, we called it as a chord PQ, and the curve that connect between these 2 points will be an arc. And we said that here, if you have two central angles, which is A, which is AOB, this central angle, with COD, if they are congruent, that means their arcs will be congruent. The second one, or the converse of this theorem, if the two arcs are congruent, like if AB is congruent to CD, so their central angle will be congruent. This was our theorem yesterday. Now, and also you see, if the two central angles are congruent, so their chords will be congruent too. Like if AOB is congruent to COD, so that's mean the line segment AB is congruent to the line segment CD. Theorem 12.4, if the two central angles are congruent, so that's mean their arcs are congruent. Here, if two central angles are congruent, so also their chords will be congruent too. And its converse says that if two chords are congruent, like AB and CD are congruent, so their central angle will be congruent too. This was 12.5. Now let's talk about here 12.6.
Teacher, do you mean about the congruent? Like they are congruent in the shape or like in the number, like in the question? They're going to say that
Congruent,
BM, for
that
example,
means they are similar in shape and size.
Like that, okay.
This is the meaning of congruent. It's different than similar. Similar, it's the same in magnitude, but it's different in shape. Now let's talk about 12.6. And 12.6 here, as I told you yesterday here, that's if you have A equal B and A equals C. So that's mean, or we can conclude that B equals C. But how? And if you say that 4 is 2 plus 2 and 4 is the 3 plus 1, can we say that 2 plus 2 is equal to 3 plus 1? Yes, the both sides are the same. Here now we have the same. If we have two congruent angles, that's mean we have two congruent arcs. This is theorem 12.4, and two congruent angles, okay, that's mean two congruent chords. So since two congruent angles is equal to, or are equal to two congruent arcs, and two congruent angles are equal to two congruent chords, so we can conclude that two congruent arcs, when we have two congruent arcs, that means we have two congruent chords. If you have two arcs are congruent, that means their chords are congruent. as we see now in this theorem here. If the chord AB is congruent to the chord CD or line segment EB, AB is like congruent to the line segment CD, so that means the arc AB is congruent to the arc CD. And its converse says that if AB is congruent to CD, that means the arc AB will be, the chord AB will be congruent to the chord CD. Is it clear?
Yes,
Yes, teacher.
yes, teacher.
Now,
Teacher, I'm sorry, but my internet today is really bad. So if I suddenly leave the period, it's because of my internet.
okay, so there's no problem. Problem 1 here. Let's use our theorem to using the congruent chords. Now, in the diagram here, look at here. Now we have two circles, and the two circles are congruent. Circle, the first circle with center O, and the second circle with center P. This means here, it means that a circle with center O, a circle with center B. Now, these two circles are congruent to each other. And given that the chords of the line segment VC is congruent to DF. Now, what did you conclude? The first one,
The arc,
yeah, if the line segment or if the chords are congruent, so their arcs will be congruent.
Want to.
So, if or since the chords BC are congruent or is congruent to DF, so their arcs, which is BC, is congruent to DF. This is using our theorem. Now get it one. Use the diagram in problem 1 here. Suppose that you are given that they are congruent and the angle OBC this one here, is congruent to the angle PDF. How can you show that the angle O is congruent to the angle P?
the
What else
corresponding
can you
sides
conclude?
of congruent triangles are congruent. Because the two triangles are congruent.
How? Okay, thank you. But how did you know that the two sides are congruent? The two triangles
Because
are congruent?
the radius is the same because they're congruent circles. And it's already given that BC is congruent to DF. That means by SSS, they're supposed to be congruent.
Bravo. That's it. Now, look at the triangle here, BOC, and the second triangle, which is FBT. Now, they told me that BC and DF are congruent. Now then, since OB and OC are the radius of a circle, so they are congruent to each other. Because the circles are congruent, so the radius will be congruent too. Now, since the three sides are congruent. So we can say that these two triangles, by did you remember SSS and SAS and ASA? So we will say that these two triangles are congruent by SSS, side, side, side. Now then, after that, since we have two triangles are congruent, so that means any element inside these two triangles will be congruent too.
So all the angles will be equal.
So yeah, since now they told me that B is congruent to D, so that's mean the angle O is congruent to the angle P. Is it clear?
Yes, teacher, thank you.
You're welcome. Do you have any question, Miss, before I will go to the second one?
No, teacher, it's clear. Thank you.
Now, let's talk about theorem 12.7.
You say
Yes.
that the radius is equal because of their sides, DF, and the other one is equal.
Can you repeat, please?
You say that the radius is equal because BC and DF is equal.
Because BC, where's BC and D? Now, see,
I mean,
BC are equal. It's given. And the radius, the OB and OC are the radius in a circle.
yeah, like you say, they are equal because like the radius are equal because of the chord, or what? Or because the radius are equal always.
Yeah, the radius in any circle, if you have any point or any line segment from the center ending with any end point of the circle, so that's mean they are equal. So if you have OB or OC or OD or OE or anyone, all of them are equal because they are a radius in a circle.
Okay, teacher, thank you.
Yeah. Now here, Theorem 12.7 and its converse. Within a circle or in a congruent circles, chords equidistance from the center or centers are congruent. Yeah, that's me. If you have circle or two circles are congruent, and if we have a point which is a center, and we have OE and OF, this OE and OF are perpendicular in two chords, AB and CD. If OE has the same distance of OF, that means the chords AB will be congruent to the chord CD. That means if you have two chords that they are farthest away from the center with the same distance, if I have here 3, here they have 3, there's a center, and the distance from the center to the chords are equal, so that means the chords will be equal, or the two sides are congruent, so they are equal, the two chords will be congruent too. And its converse says that if we have two chords are congruent, so their distance from a center will be equal. I will repeat it. If we have two chords, okay, and if we have a center here in the circle, if you put two lines from if we have here this circle and we have two chords like this as an example. If you put in the center here, if you put a line that is perpendicular on the first chord and another line that is perpendicular on the second chord, and these two lines that I draw them they have the same length, that they are equidistant, they have the same distance from the chords, that means these two chords will be congruent. And if you have two chords are congruent, so the distance, their distance from a circle will be equal. Is it clear?
Okay, teacher. Yeah.
Teacher, there is no radius here, right?
Yeah, here, yes, the radius is from the O up to the end of
To
the
the
circle.
arc
The arc,
or
yes,
any
the
circle.
end point of the circle. So OF and OE are not a radius. They are a line segment that is perpendicular on the chord.
Teacher, over here, since the chords are congruent, does that mean their arcs are also congruent?
Yes,
Yeah.
we can conclude that
Okay.
AB and CD are congruent too. They
Like
are,
we can join all the theorems that we took.
yeah, we can say that AB is congruent to CD. Let's solve now this problem here. Find the length of a chord. Now look here, these two chords, since they have the same distance from the center, they are up to the chords and they are perpendicular on them. So that's mean PR, the chords PR is congruent to the chord SR.
To SR.
Because OQ is equal to O PQRST as an example here. So then since OQ is equal to OT, so that means PR, the chords PR is congruent to SR. Then now look at PQ and QR. They told me like they are equal. Since OQ is perpendicular to a line segments and they are equal, so it's like bisector. So PQ is equal to QR.
So PR is 25.
So bravo. So the length of BR will be 25. Because QR it will be 12.5 and PQ is 12.5. So PR will be 25. Why did I find PR? Because I need to find SR or RS. To find RS, this chord, when I need to find it, since I need to find it, I need to find PR. Now, if I find PR, I will say that since they have the same equidistance, so they are congruent. They are congruent, that means they have the same size. So since PQ are congruent to RS, so RS it will be 25.
Teacher.
Yes.
Teacher, how did you know that QR is also 12.5? Like they have congruent sides, not the same side is congruent. Like the half of the side.
You mean here?
Yeah.
Now it's given, miss. Look here now. If they told you like this side, A, B, and if I draw this sign for you like this, that means they are equal. They have the same distance. So this is 5. This one will be 5 too.
But teacher, if you didn't draw it, we will not consider it
Yes,
as 0.5, right?
yes. So they are given that they are equal.
Okay, thank you, teacher.
Now, is it clear?
Like, teacher, in the quiz, when you bring us like these kind of questions, how you are going to bring it? Like, what will be the given?
Like this.
Like, you will say this is congruent to this, or this a perpendicular, like that.
You know, like these questions, inshallah.
Okay, thank you, teacher.
There we go. Okay. Now, let's solve got it 2. Now, before that, the others now. Problem 2, is it clear?
Yes,
Yeah.
teacher.
Okay, now let's solve got it 2 here. Look at got it 2. They told me that from these numbers that this chord and this chord are congruent. They are 18 and 1836. So the congruence here, the chords, sorry, are congruent. Now, since the chords are congruent, so the distance
are congruent too, so x
from
equals 16.
the center to the chords will be equal. So x will be 16. Since this is a 16, so this side will be also 16. Is it clear?
Yes, teacher.
Yes.
Now, let's go to another theorem.
But teacher, can you wait a second? I want to
yeah,
try the answer. Thank you. Okay, teacher, I'm done. Thank you.
Now, theorem 12.8. In a circle, if a diameter is perpendicular to a chord, if the diameter is perpendicular to a chord, so it will be like it is bisect the chord and its arc. If there's here AB is a diameter. Now, when AB is a diameter and perpendicular on the chord CD, when it is a diameter and perpendicular to CD, so it's come like a bisector. What's the meaning of bisector? Bisector, that means it cut the two sides to equal. It's cut the two sides to equal distance. So since now AB is a diameter here, so it will cut the chord into 2 equal halves, and it also cut the arcs into 2 equal halves. And why? Because since it is a bisector, so it will cut the sides into 2 equal sides and the arcs into 2 equal halves. So we will conclude here that CE is congruent to ED and AC is congruent to AD. So if the diameter here, so 12.8, if the diameter here is perpendicular to the chord, it will cut the chord into 2 equal halves, and it will cut the arc also into 2 equal halves. So we will say that CE is equal to ED or congruent to ED, and the arc CA will be congruent to AD. Is it clear?
Yes, teacher, thank you.
Yes.
Now
Yes.
let's see 12.9. In 12.9 here, if a diameter bisects a chord, so it will be perpendicular on the chord. So from these two theorems, we will conclude that if the diameter is perpendicular on the chord, so they cut them into two equal halves, and they cut the arcs into two equal halves. Here now, they told you that looks like it's converse, we can say. If the diameter is cut the chord into two equal halves, so the diameter must be perpendicular to the chord. It's like it's converse. The first one, they told me that if the diameter is perpendicular to the chord, so it will cut it. Here, if the diameter is cut the chord, so that means they are perpendicular. Now let's see 12.10. In this one here, they told you that in a circle, the perpendicular bisector of a chord contain a center of a circle. Yeah, that's mean if you have a chord and there's a line that's bisected and perpendicular on it, so this line must be a diameter and contain the center of a circle. Since a diameter is a line segment that's passing through the center of a circle. So here, if there's a line that's bisect a chord, cut the chord into two equal halves, perpendicular on a chord, so this line must be a diameter. And this line, since it is a diameter, it must contain a center of.
So that it will have radius.
How radius?
Like, I mean, it should have center because
Center. Oh, not
the radius too. Yeah.
Because it is a diameter, so it must passing through the center, so O will be a center.
So we just add a center for it?
How other center? Yeah, just here, nothing to add, but told me that if there's a line, yeah, he mean that if there's a chord and this line is here, this line, okay, it's perpendicular, but it's not cut the chords into two equal half. So I will not say that this is a diameter. We must say that it will bisect it's cut it into two equal halves and perpendicular, not only perpendicular and cut them into two equal halves. If this case are happen, or if these two things are happen, so that means this will be a diameter. And since it is a diameter, we say that any sides that is passing through, or the diameter, sorry, it's a line segment that is passing through a circle with a radius. So that's mean here, this line is containing a radius.
Teacher,
Yes.
for theorem 12.9, they also should be diameter, right? Not only like...
Yeah, diameter. Yeah, it must be diameter.
Okay, thank you, teacher.
You're welcome. So let's revise here the three theorems. So if AB is a diameter and CD is a chord, so it will be a bisector, since it is perpendicular on it, so it will be bisect it. So it will say that CE is equal to, or the line segment CE is equal to the line segment ED. And also it will be bisector on the arc. So it will cut the arc into 2 equal halves. And Theorem 9 here, if AB is a diameter and it come on any chord and cut the chord into 2 equal halves, so that means this diameter must be perpendicular on it, because if we have it like this, and it's like this as an example. Now this is A, B, and C. If AB here, as you see, is not equal to BC. If they are not equal, so that means this is not a diameter. Because we must say that, okay, it is a perpendicular, but it's not make them equal. So if AB is a diameter and cut them into 2 equal halves, so that means they are perpendicular to each other. And in 1210 here, that's if you have a circle, they have a chord, and they have a line. And this line is bisector on the chord, is a bisector on a chord, and cut it into 2 equal halves and perpendicular on it. So this line, it must be the diameter of a circle. And since it is the diameter, so it contains the center of a circle. Now, let's see problem number 4 here. Now, LM is 14 cm and KN is 3. They ask me to find R. What is the value of each variable? Where's the second variable? Okay, R.
Teacher, but they give us a radius.
So here, they ask me now to find R, or to find the radius of a circle. Now, from here, as you see, we have a center of a circle, which is K. So that's mean this is a diameter. And this diameter, when it is perpendicular on a chord, so since the diameter Kn, okay, I'll name it as K as Kn, is perpendicular to the chord Lm, so that's mean Ln equals Nm. Because since they are perpendicular on it, so it will be like the bisector. So it's make Ln equals to Nm. So if Lm is 14, so what is the length of Nm?
7.
7.
And Ln?
7
7.
also.
Now, what did I need? I didn't need Ln, either Nm, I need R. Where is R? Look at the triangle here.
It's a hypotenuse.
So, yeah, this is the hypotenuse,
We
or
can
R is
consider
the
it as
hypotenuse
a
of
right
a circle,
triangle.
or a radius of a circle. So if we have here, or if we have here K, N, and L, and if Kn is 3, if Ln, we find it here as 7, I need R. How can we find R?
By the Pythagorean theorem.
By Pythagorean theorem, which we say
7
R squared is 7 squared plus 3 squared.
plus 3
So
squared.
49 plus 9 is 58. So R, it will be square root of 58.
So teacher, can we consider the diameter with the length of this radius, like not in the, like with this radius that we have? Can we consider it as the diameter if we make the another side? So it will be like a big right triangle.
Do you mean like this?
Yeah.
But if make it like this here, it's like from like there's no side here, so we cannot know the length of this side.
Okay.
So r here, the radius is square root of 58. Now, what's the
Teacher,
time now?
can you go back for a little? I want to write it. Okay, teacher, I'm done. Thank you.
Yeah, let's go. Now, okay, now the time is finished. I cannot. What do you have after this period?